There's question 1. Oops. My computer's getting pretty laggy here. Question 2. Question 3. And then down here is question 4. Okay, so there's 4 different answers you need for this question using the same information that it starts with. A line contains the points -4, 1, and 4, 6. Decide whether or not each of these points is also on the line. These are 2 coordinate points in our line. And here are 4 other points for question 1, question 2, and down here, question 3 and 4. Decide if those points are also on the line. Okay, look at these coordinate points. I want you to never forget that when you list coordinate points, it's the x value first, comma, y value. The x value is written first, and then they're in parentheses. And my pen tablet is lagging so badly you can hardly read what I'm writing. Maybe I have too many windows open. Okay, now how am I going to teach you this problem? I think the best way is for me to actually graph these points. You need to graph them yourself. Don't just listen to me and then wait for the answer. You won't learn anything that way and you'll do badly on the test. So here's what I want you to do. Pause the video and go get some paper and a pencil. You need to take notes. Go get it now. I'll wait for you. Good. Have you got your paper for taking notes? All right. Now, even if you don't have graph paper, that's not important. But I'm going to show you this problem on a graph. Okay, the first point, the problem says a line contains the points -4 and 1. So let me write that down right here. If my pen tablet will work, that is. Here we go. -4, comma, 1. Do you remember what I told you? Is -4, is this the x value or is this the y value? Good. You got it. X value. Don't forget, x value is listed first. And they are in parentheses. When you see coordinate points like this in parentheses, it's always the x value first. And don't forget, the y-axis is the vertical axis. Don't forget, the x-axis is the horizontal axis. Okay, so let's plot these points. I'll go ahead and use the GeoGebra tools for this. The first point is -4, 1. So let's find that, -4. X equals -4, y equals 1, right there. Got it? And the line also contains the point 4 and 6. I'll write that down, 4 and 6. And I'll plot that point. So x equals 4 and y equals 6. Uh-oh, it's so far up I can't find it. Let me move my graph up. There we go. Point. You can see I'm not very fast with my pen tablet tool. There we go. Okay, so here is the line. I'll go ahead and fill it in with the line tool. Now, the problem gives us the other points and it asks them if they are points on the line. Well, I could plot them to see if they are on the line, but I'm going to show you how to do this just using math. The line, however, is really helpful because I can show you where I'm going to get all the numbers from. The first thing I want to do is find the slope of this line. Not that, that's a mistake. Okay, so what is the slope of this line? Please remember and never forget, slope equals rise over run. How much it rises up divided by how much it runs over. To find the rise, you can subtract the y coordinates. The y-coordinate of this point is, well, let me list the x-coordinate first so that I keep the notation the same. So this point's coordinates are 4, 6. This point's coordinates are -4, 1. Okay, now, how much does it rise? Well, it goes from y equals 1 to y equals 6. So we can say it like this, y2 minus y1. And that equals 6 minus 5. So that's how much this line rises up between these 2 points. Now, let's divide that by the run. And we can get the run from using x2 minus x1. Here's what you need to notice. 2 minus 1, 2 minus 1. Make sure you don't get your points switched around. So x2 is here, and that's 4. x2 equals 4. Minus this x here is -4. Make sure you keep your negative signs, okay? That's really important. So the slope of the line is the ratio of the rise divided by the run, the rise to the run. It rises from y equals 1 to y equals 6. And I wrote that here as y2 minus y1. Here's y2. I'm going to label this. I want you to label this in your notes. You have paper right now. Make sure you are labeling this. y2 equals 6. y1 equals 4. I'll label that as y1. See, we started here. This is point 1, and we finished here. This is point 2. So this is y1, and this is y2. This is x1 here. Where we started, we'll call that x1. And where we finish, this is x2. Okay, so use this formula here. When you need to find out the slope of a line, you can always use this formula with any 2 points that are on the line. Let me say that again. This formula works with any 2 points on this line. y2 minus y1 divided by x2 minus x1. And this means rise over run. We filled in our values. y2 equals 6, y1 equals 5, x2 equals 4, x1 equals -4. Make sure you keep your negatives straight. Okay, and then what does that equal? That equals 6 minus 5 is 1. 1. Is that right? No, look at that. I have a 5 here. Why didn't you guys tell me? That's not 5. y2 is 6 and y1 is 1. How did I get a 5 there? You guys got to help me sometimes. I get confused when I'm operating my computer and explaining things at the same time. There we go. Oops, I didn't mean to click that. I really want my notes to be perfect. y2 equals 6. y1 equals 1. And 6 minus 1 equals 5. That's what I was thinking. Okay, and that is divided by the change in x. The change in x is positive 4 minus -4. We got that from this here formula. x2 is our positive 4, and our x1 is our -4. So what is 4 minus -4? When you minus a negative, or when you subtract a negative, you actually add on that value. So 4 minus -4 is 8. The slope is 5 over 8. Let's double check that that makes sense. Has it gone up 5 units for every 8 units over? Let's see here. 1, 2, 3, 4, 5. Okay, that's 5 units up. 1, 2, 3, 4, 5, 6, 7, 8. Okay, Yes, that confirms. 5 units up for every 8 units over. That's our slope of the line. Okay, so why did I calculate this slope? Remember the problem? The problem was to find out if these other points are also on that line. Now, we calculated the slope of this line. You took notes on your paper. Do you remember what we calculated? I'm going to do it again. Why don't you pause the video and see if you can get it? Oh no, even better, do it at the same time as me and see if you can get the answer before me. Slope of the line equals y2 minus y1 divided by x2 minus x1. This is always going to give you the rise over run, the change in y divided by the change in x. Now, which point is 1 and 2? Which one? It doesn't matter, as long as you keep it the same. So you can switch it around if you want to. It doesn't matter, as long as you keep it the same. So I'm just going to say that's point 1 and that's point 2. But it doesn't matter as long as you don't get confused. y2 is equal to 6. And then y1 is equal to 1. So 6 minus 1, I'm just filling in this formula. 6 minus 1 divided by x2 is 4 minus x1 is negative 4. You should be doing this on your piece of paper. Don't just wait for me to get the answer and then copy me. Make sure you do it yourself. So 6 minus 1, that equals 5. 4 minus a negative 4 equals 8. The slope of this line is 5/8, and that's really important. Now, if the slope of this line is 5/8, then any point on the line will have the same slope. So this point, if we calculate the slope with this point, question 1 asks us, is this point also on the line? Well, let's look at these 2 points together, and let's calculate the slope of these 2 points. Okay? So let's call this point 2, and we'll call that one point 1. We'll keep that as point 1. I already have a 1 next to it anyway. So let's take the slope of these lines. The slope of these 2 points, I mean. In fact, are you confused? Let me write it again. Point 1 is 4, 1. Those are the coordinate points of point 1, and I got that from the original problem. And then point 2 is what it asked me, 0, 3.5. Oops, that should be a comma, but my pen tablet is hard to use. 0, 3.5. So this is point 1 still, and now we're changing point 2 because we want to answer the question if this point is also on the line. If it is on the line, the slope will be the same. Let's calculate slope. The slope is y2 minus y1 divided by x2 minus x1. You should be doing this on your piece of paper, not just sitting there waiting for me to give you the answers. Okay, do the math quickly and tell me if the slope is the same or not. Pause the video. Okay, y2 is 3.5. And minus y1 is 1. x2 is 0 minus x1, that's negative 4. You better check my math because I make mistakes all the time. You should be doing this together. If I make a mistake, don't make my same mistake. 3.5 minus 1, that equals 2.5. And then the denominator is 0 minus 4. That equals a positive 4. Oops, my pen tablet is not easy. There we go. 2.5 over positive 4. Aha. Now, is that equal to 5/8? I'm going to change the denominator to find out. So I want the 4 to change to an 8. Well, that would be 4 times 2. So I can change the denominator by multiplying it by 2. And then that's 8. Now, if I multiply the denominator by 2, I have to multiply the numerator by 2. 2.5 times 2 is 5. Ding, 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 ding. Look at that. The slope is equal to the original slope. So now I'm going to double check it and prove it to you. If the slope is the same, then it is on the line. We used one of the points on the line, and it is in proportion to this other point. 0, 3.5. Okay, now I'm going to graph it just to prove it to you. That point is 0, 3.5. We found it has the same slope. So x equals 0, y equals 3.5. Ding, 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 ding. There it is. I'll change that color so it stands out. Okay, so that was question number 1 here. Yes, it is on the line. You don't need to graph it to answer that. You need to calculate the slope. Okay, problem number 3. Let's try this one. There we go. So we have 2 points, and if this second point is on the line, then the slope will be equal to the first 2 points' slope, 5/8. So I'm just going to put these here. Let's say point 1. Point 1 is going to be -4, 1, and I just got that from the original information. I'll write it down again so that I don't get confused. -4, 1, that's point 1. And then point 2, can I just call that P2? That's a little easier for me. Point 2 is given here in question 2. The coordinates are 12, 11. I'm going to write that down so that I don't get confused. I still might get confused, but I'll try not to. Okay, let's find the slope using this formula of slope. You have it in your notes, right? Don't forget this formula. You need to know this all through high school, so don't forget how to calculate slope. Y2 is, right here, 11. That's Y2. And this is Y1. It's equal to 1. So fill out the top part of our slope. Y2 is 11 minus Y1 is 1. Okay, great. Now X2 is 12. I'm going to label that so you're not confused. There's no way you can be confused. And you're doing this on your paper too. There's X2 and X1. So X2, 12 minus X1 is -4. Don't forget your negative signs. You'll get the wrong answer if you forget your negative signs. This always works as long as you keep your points organized. Point 2, point 1. When I say keep your points organized, what I mean is, look again. Here are points 2, Y2, X2. So if you have Y2 on top, Y2 minus Y1, then you need X2 minus X1. And these points here, they are the ones. Y1, X1. Okay, what's the solution here? What is it? 11 minus 1 is 10. 12 minus -4, that is the same. So 12 subtracting a -4 is the same as 12 plus 4. That's 16. We need to reduce the fraction. I'll just divide each number by half. So 10 divided by 2 is 5. 16 divided by 2 is 8. Oh my gosh, look at that. It's the same slope. So if I use this point and one of the points on the line, I get the same slope as the original line. Let's graph it. Let's see it on the graph now. 12, 11. Okay, go to my graph. X equals 12. Y equals 11. I'm going to have to zoom out So I'm going to just delete all that writing, which is fine. I don't need it anyway. And go to this. Okay. Here. Zoom out. And then over here. What was that coordinate point again? 12, 11. Right here. This one. X equals 12. Y equals 11. Okay, let's plot that on here. X equals 12. Y equals 11. It's going to be right here. Look at that. It's perfectly on the line as well. I'm going to put a dot. Okay, do you have any questions about this? It seems like hocus pocus, doesn't it? Doesn't it just seem like magic? I mean, what if I didn't use this point here? What if I used this point? Would I still get the same slope? Let's do it. And I'll prove to you that you will still get the same slope. And I want you to do it on your paper too. So now I'm going to use this as my point 1. Let's use this as our point 1, okay? So I'm gonna go right. I'm still using this number here, but I'm not going to compare it with this point. I'm going to compare it with this point on the original line. So point 1 is 12 11ths. And I'll prove to you this still works. Just a second. I don't like the way my pen tablet made a mess right there. There we go. I just need to go slow. And then point 2 is 4 6. Now, am I still going to get the same slope? This is my point 1 and this is my point 2? Well, yes, you are, because you're just taking the difference in y and dividing it by the difference in x. So here, the difference in y, this is point 2 and this is point 1. So y2 is equal to 6, and then y1 is equal to 11. So our formula is y2 minus y1, fill in the numbers, divided by x2 minus x1. Fill in the numbers. Do this yourself on your paper. 6 minus 11 is -5. And 4 minus 12 is -8. And look, those negatives cancel out. So this slope is also 5/8. We get the same slope no matter how we order these points. If we use any point on this original line, this point here still has the same slope. Okay, phew! I explained it a lot. You should have taken notes and followed along. Now, you can try to do it yourself. Answer question 3. Is this point also on this original line? This is the line you're comparing it to. It's in the problem statement. Let me erase all that. So for problem 3, it's also using this line. A line contains the points da 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 da. Decide whether or not each of these points is on the line. Okay, I helped you with problem 1 and question 1 and question 2. Now you do question 3 and question 4, and I'm going to be checking your answers. Do the math. This is easy. Remember, I'll show you one more time. y2 minus y1 divided by x2 over x1. This gives you the slope of your line. You need to use one of these points, either one of them, and use the point it tells you in the problem. Find out if you get the same slope as that original line. If you do, then you are a point on the line. Okay, good job.